This is question 2 from the Mathematics Paper 1 DBE November 2023 exam. In this video, we'll be answering this question from start to finish. And of course, this question is about sequences and series. So let us get straight into it. In 2.1, we are given the arithmetic series 7 plus 12 plus 17. 2.1.1 says determine the value of term number 91. This is an arithmetic series, and we know that an arithmetic series is defined by having a common difference d. Additionally, we also know that the general formula for arithmetic sequences is Tn is equal to a plus into n minus 1 multiplied by d. And in this problem, we need to determine the value of term number 91. This simply means that the value of n is equal to 91. And then the value of a is simply the first term, which is equal to 7. And lastly, we need to determine the value of d, the common difference. And we can work this out by subtracting the first term from the second term. So that is 12 minus 7, and this is equal to 5. Alternatively, we can also work out the common difference by finding the difference between the third term and the second term, which is 17 minus 12, and that is also equal to 5. So now we simply need to substitute in all of these values into the formula. After this, we just simply need to make use of our calculators so that we can find the final answer. So 7 plus open bracket 91 minus 1 close bracket open bracket 5 close bracket. So this is equal to 457. So the value of term number 91 is equal to 457. Now, let's move on to the next question. 2.1.2 says calculate the sum of the first 91 terms. For this, we know that for arithmetic series, the sum of the first n terms can be calculated using this formula. N over 2 open bracket into 2a plus open another bracket n minus 1 into d close bracket. And so this is straightforward because we want the sum of the first 91 terms. So our n is equal to 91, obviously. The value of a is still going to be 7 because we are still working with the same series. N is 91, and therefore d as well is still equal to 5. And again, we simply need to substitute all of this into our calculator in order to work out the answer. So this is 91 divided by 2, open bracket, 2 into 7, plus, open another bracket, 91 minus 1 multiplied by 5. So this is equal to 21,112. Now the last question for 2.1. Here we need to calculate the value of n for which Tn is equal to 517. This is also very straightforward. We simply need to use our general equation of an arithmetic sequence once again. This time around, we do know that Tn is equal to 517. And of course, a is still 7, but we do not know the value of n, and d is equal to 5. So we simply need to solve for n in this equation. Okay, so let's get into it. Let's transpose 7 into the left-hand side. That will give us 517 minus 7, which will be equal to 510. And then on the right hand side, we'll be left with this product. So let us also expand it. What is 5 multiplied by n? That's equal to 5n, and then 5 multiplied by -1 is -5. And now let us transpose this -5 into the left hand side. So that is going to give us 510 plus 5, which will be 515 equal to 5n, and then we simply need to divide by 5 on both sides of the equation. So this is going to give us the value of n. So what is 515 divided by 5? I'll just take out the calculator again. So 515 divided by 5 is equal to 103. The value of n is 103. Okay, now let's move on to 2.2. The following information is given about a quadratic number pattern. So this time around, we are dealing with a quadratic number pattern. So this is the information that we are given. T1 is equal to 3. All right, and we are also told that T2 minus T1 is equal to 9, and T3 minus T2 is equal to 21. And 2.2.1 says show that T5 is equal to 111. Okay, let us interpret this information. We are told that T1 is equal to 3, so let's just write it down there because that's the first term. And we are not given the next terms, but instead we are told that T2 minus T1 is equal to 9. So we do not know the value of T2, but we know that the difference between T2 and T1 is equal to 9. And we are also not given the next term, but we are told that the difference between T3 and T2 is equal to 21. So we are being asked to find T5. We also do not know T4, and we need to work out the value of T5. That is what this question is asking us. What we can do here is we can work out the values of T2 and T3. And it's actually very straightforward. We were given here that T2 minus T1 is equal to 9. So I'll just write that equation down. We know that T1 is equal to 3, right? So we can now just simply substitute that into this equation and then solve for T2. So it means that T2 is going to be equal to 9 plus 3, which is equal to 12. All right. Similarly, we were also told that T3 minus T2 is equal to 21. And we do not know T3, but at this point we do know that T2 is equal to 12. So again, we can solve for T3. It's simply going to be given by 21 plus 12, which is equal to 33. Okay, so at this point, we do know the first 3 terms of this quadratic number pattern. Remember that in a quadratic number pattern, the second difference is constant. So in this case, we can find it from 21 minus 9, which is equal to 12. So 12 is the constant difference, okay? Here's what we are going to do. We are gonna work backwards from this second difference towards T5. Here's how we can do that. Since the first difference has a constant difference, it means that it's arithmetic, right? So we can be able to work out the next term of this second difference by simply adding 12 to 21. So what is 21 plus 12? That is equal to 33, right? And then we can do exactly what we did when we were working out term number 2 and term number 3. Note that all that we were doing, we were simply adding this difference to the previous term in order to work out the next term. Let's look at it again. T2 is equal to 12 and 12 is simply 9 plus 3. So T2 is equal to 9 plus 3, okay? And then what about T3? T3 is 21 plus the value of T2, which is 12. So 21 plus 12, here it is, 21 plus 12, and that is equal to T3, which is 33. So again, in order to work out T4, we simply need to add 33 to T3. And what's the value of T3 again? It's 33. So this time around, we are adding up 33 plus 33. And that is going to give us the value of T4, which is going to be 66. And again, don't forget that here we have a constant difference of 12. So again, we can add 33 plus 12 in order to find the next term in the first difference. So 33 plus 12, that will be equal to 45. And then we need to add 66 plus 45. And that is going to give us the value of T5. That will be 111. Therefore, T5 is equal to 111. Okay? So that's how we can work this out. Moving on to the next question. We need to show that the general term of the quadratic pattern is given by this equation. Okay, so that is going to be straightforward for us because we can simply use what we have worked out in the previous question. So this is what I mean. We know that 2a is equal to the constant difference and 3a plus b is equal to the first term of the first difference. And then a plus b plus c is equal to the first term of the quadratic pattern. So that is what we are going to use to answer 2.2.2. Starting with the simplest equation, 2a is equal to 12. This means that a is going to be equal to 12 over 2, which is equal to 6. Moving on to the second equation, 3a plus b is equal to 9. We can now substitute in the value of a here and then solve for b. As you can see, b is given by 9 minus 3 multiplied by 6, which is 18. Therefore, this is equal to 9 minus 18, which is equal to negative 9. Lastly, to work out the last constant, here is our equation. And we have already worked out that a is equal to 6 and b is equal to 9. So we are only left with c. If we solve for c here, we have 3. And then we transpose 6 to this side, and we also transpose 9 to this side. So 3 minus 6 is negative 3 plus 9, that is equal to positive 6. And as you can see, these values all match the general term that we are trying to prove. We can see that a is equal to 6, b is equal to negative 9, and c is equal to 6. That is because we know that Tn is equal to an squared plus bn plus c. You simply need to substitute in the values of a, b, and c. And that's it. Moving on to the last question. Now, they are asking us to show that the pattern is increasing for all values of L, which are the element of natural numbers. Alright, so remember that natural numbers are all the whole numbers from 1 up to infinity. Okay, so to do that, we need to focus on our general term. So remember that it's 6n squared minus 9n plus 6. So this is 2.1.3. The best way to think about this problem is to first take this quadratic pattern as a function. Let us let Tn equal to f of x, where x is equal to n. So this means that we can write this nth term as f of x is equal to 6x squared minus 9x plus 6. Okay? And now we are going to apply our knowledge of calculus. So using the rules of differential calculus specifically, we can work out the first derivative of f. So this is going to be equal to 12x minus 9. We know that if a function is increasing, it simply means that the first derivative of that function is greater than 0. So we simply need to solve for this inequality. So f prime of x is 12x minus 9. We can transpose negative 9 to the right hand side to get positive 9, and then we divide by 12 on both sides of this equation. That is going to give us 9 over 12. And we can simplify this as 3 over 4. Okay, so what does this mean? This means that for all the values of x that are greater than 3 over 4, this function is increasing. Remember that in the beginning we let Tn equal to f of x, where x is equal to n. So we can conclude that this means that Tn is increasing for all values of n that are greater than 3 over 4. Therefore, it means that this quadratic sequence is increasing for n is an element of natural numbers, because natural numbers are whole number values from positive 1 to infinity. So this is how you can work this question out using calculus. But now it might happen that at the time you are watching this video, you haven't done calculus as yet. Well, if that is the case, there is an alternative approach that you can use to answer this question. We are still going to let Tn equal to f of x, where x is equal to n, and so this will be our f of x. Now, in this function, we can see that the value of a is equal to 6 and it's greater than 0. So remember that if a is greater than 0, it means that the graph of the quadratic function is concave upwards. All right? So it means that in order for us to know the values at which this graph is increasing, we simply need to know its turning point, because on the right hand side of that turning point, that is exactly where the graph is increasing. And in order to work out the x value of the turning point, we can use the equation x is equal to negative b over 2a. And in this case, we say that b is equal to negative 9. So this will give us a negative 9, and a is equal to 6. I hope you can see it already, because what we are going to get here is positive 9 over 12, exactly the same as this value we had gotten when we applied differential calculus. And of course, 9 over 12 is equal to 3 over 4. And as we had discussed, 3 over 4 is simply the turning point of the graph of this function. If, for an example, this graph is like this, Here we would have the turning point, or that would be our line of symmetry, with a value of x equal to 3 over 4. And clearly, for values of x that are greater than 3 over 4, this graph is increasing. Therefore, f of x is increasing for values of x that are greater than 3 over 4. And therefore, we can conclude that our quadratic sequence Tn is increasing for n is an element of integers, which brings us to the end of this video. As usual, don't forget to press that like button, give me your feedback in the comment section below, and most importantly, subscribe to this channel so that you do not miss out on more good tutorial videos like this one. See you on the next one. Goodbye.